think I'm live. No one's watching, but I think I'm live. Ooh. I might be live on Twitch. I don't know if I'm live on YouTube. This has been an interesting process learning how all this stuff works, and I am almost certain I'm doing it all wrong. So let's see. Like always, first try. So if I go to my YouTube channel, am I live streaming? Am I live? It says I'm live. Ooh. Ooh. I have a... Why does it say I have 2 viewers? Am I viewing myself? Do I actually have a viewer? That would be insane. Who's trying to watch me right now? That's... Alright, let's see. Uh-oh. Uh-oh. We're gonna get feedback. Alright, let's try vertical. Hey, I'm vertical! Alright, let's see. Hang on. I gotta look at the camera to look at me looking at the camera. Okay, that's what I thought. We only have 1 viewer, and that's myself. Wonder why it says I have 2. Alright, so that appears to be working. Stand by while I make sure we are live on the Twitch. I don't trust technology, having worked with it for years. Okay, I see it on Twitch. Alright. Alright, so, Awen. This is my super cool, let's say acquired art? Temporarily acquired art? For this open source, not being paid product, to be clear. But Awen is going to be my game engine using C++. Hopefully, C++ modules, C++ 26 at some point. I know GCC 16, which isn't officially released, has some C++ 26 features, including, I think, reflections, which is really cool, because I do want to make use of that to build out the whole, like, signal slot interfaces, serialization, that kind of thing. I think there are some libraries out there now, open source libraries, that provide some of the serialization stuff, which is really freaking cool with C++ 26. Clang, I'm not 100% sure where they're at on things. I have 23 in the pipeline. I don't know if that's an actual official release, or if AI took me literally and said, hey, I will grab you the latest. But that is what we're using, and the code seems to be passing, so that's cool. And then Visual Studio, I don't have 2026 yet installed. I'm still rocking 2022. So I'm not going to be diving too deep into C++ 26 features quite yet. I am thinking, for now, we want to get something up and running. We want to motivate ourselves to actually make progress on this. So to recap, on my last stream, I created a repo called Awen, made it public, MIT license. Again, you never know with projects like this. Open source is its own beast, and it also depends on the community you're able to get behind it. So in the meantime, MIT license, all that's good. Most of what you see in this repository is to get a Hello World app up and running called Awen, which is an executable to print Hello Awen. Like, all this entire project was to get that one Hello World application up and running. Which seems crazy, but work with me. Check this out. Boom. I've got all kinds of passing pipelines. We can build on Windows. We can build on Android. We can build on Mac. We can build WebAssembly. We can build on Linux. And we also do different types of analysis, like linting, static analysis types of things, formatting. The big one that I really like has always been Clang Tidy. So I've got a clean, tidy job here that will run on the git diff of files that you push up, so it goes relatively quickly. I mean, we're not running any code right now, so 48 seconds. And again, all of this was to get a single application compiling in the pipeline using GitHub Actions. And so almost inevitably, as soon as I start writing any actual code, these pipelines are just going to explode. Don't ask me how I know. So in the meantime, I think the next step for this project is to get some graphics up and running, to get a window up and running. And with C++, with the millions of ways to build your project out and to handle your dependencies, we got to figure out, first of all, which graphics library, window library we want to use. I don't necessarily want to write all that from scratch. I've done it before. It's not fun, and it's a lot of like tinkering with operating system APIs, and then also having to make sure those, whatever APIs you tinker with, you have like a consistent set of code that can work across all these different platforms. Fortunately, that's where open source comes into play. And so off the top of my head, I am tracking an open source project called Raylib. I know that's a pretty popular one. I have messed with it a little bit. It is very, very easy to get graphics up and running, get a window up and running. And it is so featureful. It is so freaking awesome. That being said, it does a lot of hand-holding that could potentially limit how I want to design my game engine, especially like the rendering backend. Because if I want to end up using a scene graph and I want to manage how I batch my own vertices and geometry, that kind of thing, I don't know. Like, I know Raylib can do it, but it does it via its RLGL wrapper. And I kind of want something maybe a little bit more closer to the metal. So we'll see. I'm going to have to play with it. Because eventually what's going to happen is I'm either going to start making progress and be like, yeah, let's do low-level programming. Let's do this. And then like 3 hours later, it's like, oh, crap. I'm not making any progress. This is tough. So then maybe it's like, okay, let's go back to Raylib. But the other one off the top of my head is SDL3. SDL3 wraps all kinds of graphical backends. It has a new GPU rendering backend, which is basically a layer on top of the latest graphics APIs, Vulkan, DirectX, Metal, maybe Web GPU. I'm not 100% sure there. The downside to SDL is it takes a little bit more effort, if not a lot of bit more effort, to get that GPU project up and running versus something like Raylib, which just does everything under the hood. So I've got that decision to make. I'm torn. I've used both. The ease of getting Raylib up and running and just how many features it has is just second to none. And then, for game engine, you also got to think, well, you're going to want network communication, possibly audio, most importantly, controller input, right? So you're going to need to do controller input. And if I can just pull all that in with a single dependency versus having to pull in all kinds of separate dependencies, it just makes life a little easier. Because once you start learning an API, then you'll have a good familiarity with a single API versus having to learn a bunch of stuff. So in the interest of getting anything up and running, I am leaning towards Raylib, because worst case scenario, we can use Raylib to start sketching out how we want our game engine to look. And Raylib can at least give us the idea of like, okay, we need something that handles graphics, we need something that handles creating the window, we need something that handles creating events, so on and so forth. And I think, I hope, Raylib plays nice with C++ modules. I know there are other third-party libraries that don't play very nice with C++ modules, especially if they define a bunch of templates and static variables in header files. That can cause some heartache with C++ modules. And I do want to use modules as much as possible, preferably only modules. So let's do that. Let's just hit the ground running. Let's do Raylib. So how do I get Raylib into my project? That is the next question. So I've got a directory of CMake configuration, a little bit of C++ code for my executable, and we want to pull in Raylib. Now, I don't remember off the top of my head what the Raylib package name is in VC package, so I'm just going to take a look. I should be able to look. Oh no. Oh no. We're already hitting the ground running. Do I have it pulled down? It's up to date. How is this already screwed up? I just started streaming. This was working. I think I told VS Code to ignore it somehow. I don't know if I wanted to do that. You know what? Let's try and run a CMake configure real quick and see what happens. Maybe this will auto-fix things for me. Oh gosh. Nope. So far, oh no. Oh boy. Oh jeez. So I made a bunch of changes last night that I only tested on my Mac and in the pipelines, but I didn't test on Windows. So this is what happens. Let's see here. This is fine. That's just a warning. It can't find gtest, so I probably screwed up my CMake presets, since that is what I've been working with. So this might be a case of I will throw this to AI to start looking at it while I'm also digging at this in parallel, because if it can see something obvious, then that saves me a lot of time and headache. So we just hit enter there. But my suspicion is the fact that I can't expand VC package. What is going on there? It should show up here. And it's not. It's my... if I do a git submodule update? Ooh. Something's happening. I may have beaten AI to the punch. The Git repository has too many active changes, only a subset of Git features. Yeah, that's fine. Alright, I'm gonna wait to do anything with the AI because this seems like I may have figured out what was going on. Okay, so VC package checked out. So now I can... There we go. Okay, I have VC package. I don't know why... It's saying I deleted the VC package repo. Like if we go to my GitHub project, like I added VC package gtest update platforms. I didn't delete it. Am I on the right branch? That's good. Okay. Okay. Right. So this can happen. VS Code might take a sec to parse and figure out the state of your project. So that's on me. But that should be good now. And the whole reason I wanted this was to check out the ports and see what it's called for Raylib. Element OP, QR, Raylib. Ooh, and Raylib has a GUI too. Oh, that's cool. Also, the benefit with Raylib and SDL is I'm 99.99% sure they work on Android and WebAssembly as well, using like GLES, I think, and WebGL. So that means for Awen, the project that I just spent a significant amount of time last night getting up and running on a WebAssembly pipeline and an Android pipeline, I should be able to use this to get graphics up and running for that too. Let's see here. Okay, so it's just called Raylib. So ABCD. So I should just be able to... Raylib. And once I set that, I should be able to configure CMake. And it should start downloading it and dependencies. Now, one thing we might run into with the GitHub action runners is I basically set up a bare minimum Docker container for all of these. So any dependencies that Raylib might need on like Linux, we might have to update the Docker files to contain them, which shouldn't be a big deal. Ooh, another issue we might run into, because I was playing around with this last night, I configured VC package to only do release builds instead of both release and debug. And that's because it saves a lot of time compiling debug files for dependencies that I'm almost 90% of the time am not going to need to step into code and debug third-party dependencies. If I'm doing that, then I'm getting pretty into the weeds, and I'm not necessarily trying to do that right now. And also from the CI/CD pipeline perspective, you get through the pipeline a lot quicker because you're spending less time compiling. And I've got this stuff being cached, so that's not the end of the world. But even the initial compilation will go a lot quicker when you only have to build release and not debug. The only concern I have is on Windows. Sometimes Windows will get really finicky with linking release libraries with debug libraries, or vice versa, because the different dynamic debug compilation flags and linking flags that you configure don't always play nice on Windows, whereas on Linux or Unix systems, you can almost always, I won't say always, but almost always, just link release binaries to a debug or release build. All right, so CMake configured and generated, so that's good. Ooh, I stopped paying attention to my AI, and it is still going. I don't know if anyone can see. Oh, what did it do? It's making changes. It's got a mind of its own. Wait, what's happening? No, stop. I think I'm good. I'm good. Yeah, it's great. But that one's on me. I ignored it for too long, and it got upset with me. Let's see. What did it do? Okay, there's no git changes. So one of the things I like to do when messing with AI is I like to keep track of what I have changed and I'm happy with and I'm not ready to commit by staging it. And then that way, if AI does end up making any changes, I'll see the diffs and be able to do essentially a code review on it. All right, but we configured successfully, so Raylib was successfully built, so we will compile. First try? First try. All right, so let's make sure before we even start linking anything that my Hello World app still does its thing. What are we? We're on Windows, installed, bin, Awen. All right, we still got Hello Awen. Sweet. All right, so we need to get a window up and running with graphics, preferably using CPP modules. So how in the world do I start? I think to start with, since I am still kind of learning, I don't know off the top of my head all of Raylib's API. So you have a couple of options. Go to GitHub, read the documentation, that kind of thing. Or Alright, AI is going haywire again. It's trying to do the CMake configuration to verify everything works, but I think I can handle that myself. So if I configure... And the reason we're configuring is to make sure the CMake picked up the right. Then we'll compile, and it compiled. Alright, so without reviewing the code at all, do we think we're going to get a triangle out of this? That would have been too easy. Okay, couple of suspicions, let's say. So let's see what's happening here. First, we can take a look at what was changed. So our CMake list was changed. We are linking against Raylib. We did find Raylib. I don't like that it found it here, so I will move that once I'm ready. We link against Raylib. We use Raylib. Okay, so I'm not seeing anything egregious here. I would expect this to work, so I'm going to go ahead and clean up. I want this here. I haven't decided if I like having the category or the accessor type in its own line or not. Still playing around with that from a formatting perspective. I don't know if there's a almost like a CMake formatting tool like we use for C++. Okay, so we find Raylib, we link against it, so that's good. What could we potentially be doing wrong here? It is possible this worked, and it got hidden behind a window that I'm not paying attention to. So I'll keep an eye on that. Initialize the window, that looks good. Begin drawing, clear, draw triangle, draw text, and drawing. So the only other thing I was worried about is on Windows, if we built as a DLL, well, then that could be the issue, because on Windows, it typically looks for your dependencies in the same directory or in a path. Except, where is my VC package installed? Maybe that's the issue. Oh, wait, we're doing debug. Duh. Alright, so we come in here. Yeah, Raylib's a DLL, so that's almost certainly what happened. Let's verify. So what I can do here is I can... Oh, does PowerShell use C copy? Can I do that? So can I copy... build... Whoops. Is it not autocomplete? Really? Oh, I'm... Okay. Build, x64, debug, VC package installed, x64 release, bin, raylib.dll, and let's copy it into our installed directory. See what happens. Alright. Then, can I run it? Ah, dang it. Alright. I tried. So, I gotta figure out what's going on there. Is there oh, there's other dependencies. There's GLFW3, so that's the windowing library that Raylib uses under the hood, so that makes sense. So let me copy that as well. Third try. Too easy. All right, the game's done. Success. But seriously, we gotta actually fix that DLL issue. There's a couple ways we can go about doing this. At a bare minimum, when we run cmake install, when we call this build install target with DLLs, we should be able to pull in any of our shared object libraries, our dynamic link libraries, into the executable directory or into a lib folder if you're on Linux or Mac or Android. Mac gets a little weirder because they have like everything self-contained. But I think CMake provides us some of the tools to automate this. So I am thinking, and I've done this somewhere before, so I'm gonna look at a project I have on GitHub, see what my solution was. Where did I do that? Do it in here. I did not do it here. Did I do it here? Ah, I did it here. Okay. So I think what I can do is we'll create a little CMake script and call it install runtime artifact. I'll be honest, I bet AI could generate this for us as well. I don't think this is doing anything crazy. I'm just going to copy and paste this from my repo here. So this will, when given a target, get its when I say target, I mean a CMake target. So that's going to be like when you do add executable, add library, add interface, something like that. So we'll get the type, and if it is not a static library, we will run the install imported runtime artifacts command. So this is something that comes from CMake with our target, and our destination will be the bin directory. I don't know if that's true for other platforms, but for Windows, bin directory is what we want. So I might have to update the script to also support Linux. We'll have to see. Linux is different than how Windows is. Windows looks for your libraries in the directory of the executable first, whereas Linux likes to look for like more global directory spaces. So like user lib, user local lib, lib64, that kind of thing. And then there's always the LD library path environment variable you can specify on Linux. So I'll have to play around with that, see what I want for Linux. But for Windows, this should do the trick. So we want to include this. Okay. And then we need to use this. So if we know the name of our target, which is, I think, glfw and raylib. Now, the other problem is I would have hoped if this was an imported target, there might be another way to automatically do it, and maybe I'll use AI to ask. Maybe it will know better than me. It's sometimes hard to keep up with. All the dependencies. So here I want to specify, I think, raylib and glfw3 question mark. Is that what I did? No, that's not how I do that. I need to use the actual target. So I probably need to, I mean, if I'm going to be linking against this statically at some point, then I'm going to need this anyway. So we'll do raylib glfw. I don't know if that's how you actually find glfw. VC package will tell you, but I don't have it listed as a dependency. So let's just see what happens. You know what? I'm just going to nuke the build folder so we can get a clean picture of what is happening. Hit configure. build. This looks promising. It installed... Ooh, no. It installed raylib.lib. Maybe it was only glfw I needed in my directory. Maybe I am statically linking. Does this run? No, I need both. Okay, so why did it install raylib.lib? That's annoying. Programming is never easy. Install imported runtime artifacts. Is there another way? You know what? Alright, I'm gonna ask AI. Let's see what AI has to say. Instead of me spending hours digging through the internet documentation. So I want to... Here we go. Okay. I want to ensure... what do I call this? Project dependencies from VC package are installed. See, I thought VC package automatically handled that for you. I don't know. I want to ensure project dependencies from VC package are installed when I install my project. In Awen CMake list, I tried to do this myself with install runtime artifact, but it grabbed raylib.lib instead of DLL. Ideally, I shouldn't need this, shouldn't need a custom function at all. What could you take a look and provide some suggestions? Alright, let's see what it has to say. Right, the other, I mentioned this, the other solution here is we just say, hey, to heck with dynamic libraries, let's just statically link and be done with it. That has its own problems and issues we'd have to fight through too. And eventually I'd like to support both. So the more time I spend on it now getting that figured out, the less stress I have to have once this project gets bigger and more complex. But these issues I'm running into right now, it's kind of why I wanted to get raylib up and running in a main executable, so that issues like this crop up, we can just address them now versus being head deep into architecting how we want our APIs to look, what classes we want to build, we want to wrap raylib in a graphics library, that kind of thing, and then run into these issues and have no idea what's going on, versus just start using the APIs immediately, figure out what you like and how you want to, what you don't like and how you want to work around it to build the APIs you're actually trying to achieve. Alright, the AI has a clear picture, and it wants to see if it's using my custom function anywhere else. I really just don't want to use it if I can avoid it. I always prefer to use tools and options that are maintained by others so that I don't have to maintain it. I don't have to worry about debugging it, all that fun stuff. I know, and I think it's all dependent on whoever maintains these libraries, but I'm pretty sure CMake allows you to define, inside these imported types, allows you to define where your install targets end up. I could be wrong. I might be making that up. Come on, AI. Give me something cool. Something weird is happening with my OBS. I don't know if it's because of the plugin. So I want to check. Alright, you ready for the audio inception? Okay, no audio inception, we're good. Alright, yeah, so no, it's just me. I'm the viewer. That's okay. Alright, let's see what's happening here. Do I have it open somewhere else? I'm not tracking. No. I don't know why this chat window isn't. Just close the dockable window. If you'd like to show it again, use the docks menu on the menu bar. Hey, there we go. Something's okay. There we go. All right, my empty viewers. If you're able to chat, I can now see it. I think. I don't know. I'm still trying to figure out how all this stuff works. Still learning. I have no way of knowing how any of this. Interesting. I have two different chats for YouTube. I don't know how that works. Okay, so... Oh, boy. Oh, man, I'm not liking that. No, that's not what I wanted. Ugh. VC Package should do this. VC Package has a way to, it's like called app dependency local, I think. I'm not crazy. VC Package app local. Oh no, am I crazy? This didn't bring up anything. No, it's like VC Package app dep, app local deps. See, I'm not crazy. Like, it should be automatically copying my dependencies. Alright, whatever. Alright, I think I'm going to try and fix that offline. So in the meantime, what I'm going to do is just set everything to be static. So we'll statically build our dependencies and then statically link, and then we don't have to worry about the DLL issue. Because that's just going to be a lot of me sitting and thinking and tinkering versus I want to make some actual progress. So, if you are not familiar with VC Package, the way we would do that, well, with CMake, honestly, is it's build shared libs is a variable, but I am going to define that in... Where should I put that? Because we need to tell VC Package to build statically, and then we also want to build our own library statically. So I'm probably going to put that with my compiler flags. I don't want it with my flags. Maybe I'll just... I don't like putting CMake variables in my CMake files anymore. I've worked with CMake for over 15 years, and I used to do that. I used to do that all the time until CMake presets became a thing, which just kind of like changed my worldview on how to do CMake configuration. Because ideally, you can build your libraries, your applications to be, if you put in the effort, as you can see, this takes effort, to be so flexible that you hand over your repo, your source code to someone else, and it's on them to provide their own CMake variables. On top of that, our project can provide a set of presets, so you're allowed to use our presets, but we aren't going to force any flags on you to get this project compiling and running, but we will hand you a collection of what flags we use, we being myself in this case. But this is stuff I use professionally as well. So that's why I hesitate to put this build shared flag in my CMake list file. I don't know if I actually want it to go in my compiler flags. Yeah, I guess we can. Let's just do it here. I mean, some of this stuff we probably want it to always be static anyway. Forget if Android wants everything built dynamically. But we're gonna say false, so that means for Android, any libraries Awen builds will be built statically. So this isn't touching VC package yet. We still have to mess with VC package. That's gonna be its own thing. But this will save us a little bit of headache until I can spend more time getting all this fixed. Visual Studio. Yeah. Okay. So now, VC package. VC package, all that stuff gets defined in VC package's triplets. And so these are like VC package's default triplets that it comes with. And you'll see there is a Windows static MD. So that's the multi-process, multi-threaded dynamic linking. So that's where we will still link against the dynamic runtimes on Windows, which means we don't have to package our own runtimes with our application necessarily. But VC package dependencies will be built statically. So that's kind of what I want. But the problem is, I also only want to build release libraries. Which means I might have to run my own custom triplets. Unless there are some community triplets that do that for me. Ooh. Ooh. Here we can basically link the Windows runtime directly into our applications. I don't want to do that. You would do something like this if you just want to absolutely have a drop and run. Like you want to run it off of a USB or something, right? You want to make sure you have all the dependencies you need, kind of thing. But it does make your files a lot bigger. But yeah, no, this is what we want. So we want Windows static release, so that's good. So that covers Windows. Does Mac and Linux have that as well? Linux is default static, I think. It is. Okay, so we can... the issue is on Windows. I think everything else is good, because everything else, I think, defaults to static. Ooh, Mac might not. No, Mac does too. Yeah, okay, so this might just be a Windows thing. So I want to grab the Windows static release. I'm going to rename it so I can copy the text of the file. And then in my preset for my host on Windows, I want to use static release. I might have to reload Visual Studio because it sometimes struggles to parse these presets. It turns out, even though I'm using CMake presets, because I'm using it in VS Code, not Visual Studio, it will, it doesn't actually use presets. It parses all of your JSON files to create standard CMake inputs and then uses those instead of like running the presets on the command line. Ran into a very interesting bug in order to figure all that out. Alright, so I think we're good now. Let me verify what I've changed to make sure I didn't screw something up. Oh my god. I don't want to... Okay, let's do this one file at a time. We are importing Raylib, correct. We want that. CMake. We don't want all of this runtime dependency set nonsense. So let's get rid of that for now. I really don't want to have to write custom CMake scripts if I can avoid it. So that should be good now. Main. We did verify Hello Triangle does work. With a little bit of manual copy and paste. And Until I come up with a better solution, I'm gonna not commit that. Android NDK will be built statically, which I'll have to learn. I've compiled C++ for Android before in the past. It can be a headache sometimes. I forget if Android prefers you to do DLLs or static. I feel like it might be DLLs or SOs. That looks good. We're telling a VC package to build static libraries on Windows. Okay, so let's see what happened here. This did its thing. Okay, everything configured. Let's see if we can compile. Everything compiled. And then let's verify we don't have anything in our build folder or in our installed. We do. So let me delete that real quick and run it one more time. So now it only installed our executable. I did all that. There's no libraries here. All right, let me delete the build directory real quick. Let's try one more time. Installing our dependencies as x64 Windows release. That's not right. That's not right. I may have missed a preset. I wonder if I have to set it. I set it on the host. Oh, that's the host triplet. We want the target. Okay. A little complicated, but one of the things the VC package can do is allow you to specify the triplets to use for a host and for a target. The host is, hey, this is the platform you're going to be doing your compilation on. So in this instance, it's Windows. The target is what you're going to compile to, also Windows. This becomes more important when you're dealing with like packages, ports that come with like executable tools that you need to run, where you'll want them installed or compiled differently on the host system versus like, say you want to cross-compile to a target system, so you compile your tools x86-64 on the host, but then your target might be ARM64. That's where this comes into play. I have this all split out so that down the road I can add more features more quickly and easily at the cost of me forgetting that I did that. So let's try this again. So we'll delete the build directory. Figure. And so hopefully we'll not see x64 Windows release anymore. We'll see x64 Windows static MD release, which is what we actually wanted. Cool. Alright, so before I build and say first try again, I want to verify that I actually got my static libraries. And I know they're static because there's no bin folder here with the DLLs, so that's all I have. And it's interesting that we now see there is nano svg, glw3.lib, because Raylib probably depended on these before, and it didn't need to expose them for us to link against, because that all got pulled in with the DLLs. Now my suspicion is we'll probably have to link against these at some point, explicitly. So I'm going to compile. Check it out. Raylib has an unresolved external symbol referenced in function init platform. Ooh. I am really hoping this isn't an issue with statically linking a release library with a debug build. Like I said, Windows can could get really finicky, but I was hoping that maybe it didn't anymore. Especially this warning here: default lib MSV CRT conflicts with use of other libs. Use no default lib library. I don't know if that's our issue though. Our issue, unresolved external symbols. So we can Google this. We can figure out what library requires this. I'm hoping it's just going to be like GLFW or something like that. We can also just say, hey, AI, I'm just going to copy this and say, hey, our code's failing to build. I'm not even going to say that. I'm just going to say error. Let's see what it, oh, okay. So yeah, we're probably not linking against some Windows runtime libraries. I do recall this. I think Raylib did need this before. In fact, I bet I have this in my GitHub. Let me... where would I have done this? Would have been in a library I wrapped around Raylib. Oh, but I bet I'm dynamically linking, so that's probably not a non-issue. This is only popping up because I'm statically linking. When you link static libraries that have a dependency on other static libraries, they don't get to just pull them in, so you have to be a little bit more explicit with it. Which is kind of a downside for maintaining static libraries. Pain in the butt. Doesn't automatically work. Alright, let's see what changes the AI made for us. See if I agree with them. Oh, huh! It's fixing our warning here. Wait, what? Did it not make a change? Crazy? AI said... Added WinMM to target link libraries. These symbols live in WinMM lib, Windows Multimedia API used by Raylib's timer code. Okay, so it is Raylib using a Windows API. A little annoying, but you know, it's when you're using libraries written in C, they don't have as many options. What do I do here? If I was me, what would I do? I would look at the file itself, because maybe that's not correctly showing what's happening. Yeah, there it is. Okay. Except, this is a Windows-only thing, so we actually need to do... I need to throw this in here. Wow. Okay. Oh, wrong pipe. Now we're hitting the issues I was worried about. On Windows, trying to link release and debug files, we get a iterator debug level mismatch because our release binaries don't have the debug levels defined. But our executable, which is being built with the MD dynamic debug flag, which automatically set by CMake for us, it does have it. And this isn't playing nice. So for Windows, I think I have to go back to using both debug and release libraries, unfortunately, which just means that compilations take a little longer the first time around. Pipelines will take a little longer the first time around. Once dependencies get cached, that'll be a non-issue. I was just kind of hoping, even though I know better. Okay, so the way we fix that is we go back to our presets, where we tell it we were doing release static, and we just need to do static. Static MD though? That I don't know. So if we look at VC package triplets, it is static MD. Okay. So we're just doing this, and we also want to make sure our host is using it too. Once we get more involved with like cross-platform compilation, that's when you might start seeing host and target differ from each other. That gets a little bit more complicated. Alright, let's configure CMake again. It's going to have to now build debug, and we should see that somewhere. Yeah, right here. So now it's building debug, and it's building release. Both static still. And we're just doing static because I'm too lazy and I don't want to deal with trying to figure out how to make sure all the DLLs get copied where they need to go. I'm almost certain there's a clean way to do that. I don't remember how to do it off the top of my head. It's been so many years since I've had to mess with that. And this is my project, so I get to do what I want. Compile. All of this work to get a single triangle to render. First try. Oh yeah. Now what do I do? Now it's probably gonna get more complicated. I could just, oh, you know what we could do? Before we get heavily involved with figuring out how we want this engine to work, serialization, physics, this is gonna be 2D only. I'm too much work for 3D. Physics, inputs, frame timing, collision detection, all that fun stuff, rendering engine, scene graph, all that stuff that goes into a game engine. Before we figure any of that out, something I've never done, so maybe that's what I'll try and learn to do, is can I get this Hello Triangle to run on my Android phone using my game engine? It's a game engine, right? If it doesn't play games yet. If I can get this running on my phone, and in the browser using WebAssembly, I think I've got it made. Because then I've done something I've not really done before. I mean, I've done this before, but I've always used other frameworks like Qt, Godot, Flutter. I've used Flutter to do this. Like, there's all kinds of tools out there that do this, but I've never written it from scratch myself. Because that means I'm probably going to have to handle my own Gradle configuration for Android. I'm assuming I'll have to handle the Android entry point with a jar file, which I've never done before. Hopefully I don't have to do too much. Maybe it's like automagical. Because I think VC package might help with it. I'm not 100% sure. So hopefully we can do that. So now that's what I'm thinking we do is Hello Triangle on Android. But before that, let's commit and verify things still compile. I also want to be like, hello, Awen. Hello, is it hello, Awen triangle? I think that makes sense, right? Hello, Awen triangle. Ooh, all kinds of hard-coded math. Cool. I want to make this a branch. Hello, triangle. All that work. To add 20 lines of code. So we'll create a pull request, and we'll see if the all the pipelines play nice with it or not. My first suspicion is like the Android, the Linux, maybe even Mac, they're not going to have all the dependencies for Raylib, and so we might have to update the Docker files. I got glue stuck on my monster can, so I'm just picking at it as I wait. There we go. Finally, that was driving me crazy. Oh, there's still bits of glue on it. But yeah, so we've got Android running, a Clang debug build, a GCC release build. We're running a format check to make sure Clang form. Ooh, that's okay. We knew this was going to happen because we don't have these dependencies installed in our Docker file. So what I can do now is copy this. Oh, it looks like GLFW3 is what depends on it. Yeah, because you need the X11 libraries to, create a window. Handle the cursor. OpenGL drivers. There might eventually be some other errors, but we can at least get this installed. So what I'm going to do with AI, because I don't necessarily know all the package names off the top of my head in Ubuntu's apt repo. So I can be like, hey, install the following Ubuntu pack. I don't even need to say Ubuntu. Install the following packages in the Linux dev container. Do we need it for Android? We might need it for Android as well. Actually, I mean, our pipelines will tell us, right? That's why I made them. So we get to know what our answers are for what goes. Oh, everything is red. Oh my god. Everything is awful. Let's see. Does Android have the same issue? Looks like it might because it can't find GLFW. Or no, actually, it compiled everything. You just can't find GLFW. Alright, so this might be something we'll have to load into a local dev container to figure out what's going on. That's Android. Linux will get fixed pretty quickly. Ooh, WASM. The WASM is not working either. Also can't find GLFW. You know what? That's fair. Because and you know what? This might be the case for Android as well, actually. GLFW is a windowing library for desktops. Android isn't a desktop. And so my suspicion is GLFW... I guess we could look, right? GLFW... My suspicion is GLFW doesn't support Android. We have to use something else for Android? Yeah, so we can look at the GLFW code here. So Cocoa, which is what? Is that macOS? EGL, which is Windows. Linux, macOS. null. So if you don't have a windowing library available, you can still, I'm assuming you can still make use of some functionality. POSIX, Win32, X11. Yeah, there's no Android here, which kind of makes sense. But I thought Raylib supported. And this is where I don't know what I'm necessarily doing. I know we probably need something to create a window for us on Android. I don't know what that looks like. It almost certainly requires Java in some fashion, a jar file. Is that Java runtime? Like, even if Raylib supports Android, it might be just the rendering that runs on Android versus creating a window library or a window. Let's see, working for Android. Android requires a set of tools to do all the build process to generate an APK. We need the OpenJDK. So I do have Android Studio installed on my computer. So that's not an issue. See, Android Studio. I've had it installed because I do perform Android development using Flutter. Android SDK, I have all of that. Android NDK, I have that in a Docker container. I don't know if I have that on Windows. Compiling Raylib for Android, so we clone Raylib. I mean, VC Package has already built this for us for Android. That's not the issue. This also might be the quick and dirty solution here might be to say, hey, AI, make work. And then AI will tell me where I went wrong. I have all of this. I'm expecting to see, so maybe Raylib does support creating a window on Android. Guess we can look at the code. Platforms, nope. Not there. This is, you can kind of see how I go about digging into documentation and reading other people's code here. There should be, well, I guess if Raylib's using GLFW, but GLFW doesn't do Android. GLFW, let's just do a broad search for Android, see if Raylib has anything. Android native app glue. This makes me pull source, so that makes me think like events and stuff like that. Is that Russian? Is Raylib Russian? Okay, so this does make me think this Raylib does support Android. We just gotta figure out how to make it happen. Yeah, there's an Android manifest file here and everything. Okay, build.zig. Raylib uses Zig? What? When did that happen? I tried to use build.zig for my projects because Zig is a programming language that is on the up and coming. Built on top of LLVM, and it has, because of that, it can do like Windows or CPP cross compilation to all kinds of platforms. And maybe that's something I can do, because the idea would be you replace CMake with Zig. But I was having a really hard time integrating VC package to be automagical with Zig, because Zig, as far as I know, at least at the time, wasn't automatically producing compile commands that a lot of these tools I use require. So I never really made it that far because it was going to require me writing a bunch of my own custom code. And again, when it comes to these build configurations, I really like to avoid writing custom code if I can. Yeah, that's actually awesome. They use Zig and CMake. But yeah, Zig would be kind of cool to use at some point. I have lost track of what I was doing, and that was getting Raylib compiled on Android. Getting Raylib compiled on Android. And it is failing because it can't find GLFW. Because I'm pretty sure we don't need GLFW for Android. Okay. Let's see what progress it made here in Dockerfile. Okay, so it added the, this should fix the Linux build. So let's go ahead and fix the Linux builds. We can take a look at this real quick. Linux Dockerfile. X11 display libraries required by ArrayLib and similar. Yep, that makes sense. All of this makes sense. So let's go ahead and get this pushed up. And then I think I'll push that up, and then I think the other thing I'll do is get the Android environment kicked off. So we go into reopening container, select the Android dev container, and that should start to build. While that's building, we can take a look at our pipelines. These are just building our Docker files, so they pass because we didn't make any changes to the files. My friends are having a bonfire tonight. Don't know if I'm going. Having a lot of fun talking to myself. So we should start to see the Linux. Ooh. I always speak too soon. What the heck's happening? AI failed me. AI was supposed to be the chosen one. It's supposed to know what the package names are, because I didn't know. I'm able to locate packages. Yeah, of course you weren't. I'm gonna let this finish building first. I also thought VC package would tell us, maybe I looked in the wrong spot. This should tell us what the package names are for Ubuntu. So where was that? Was that in a previous build? I'm dumb. It was right here. I'm done. But that's okay. We played the waiting game. Alright, while we're waiting for paint to dry, I'm going to use the bathroom. Be right back. Let's see where things are at. Alright, we are in the dev container. I'm going to go ahead and make a change to that Linux Docker file. What? What's happening? Boom. Okay. I don't need this. I don't like... Okay. I think that's fine. I need to manage unsafe repos so that I can push this from the dev container. But I am in a WSL environment working off of the disk of my Windows system, so this will be a little bit slower than a normal Linux environment. Maybe by a little bit, I mean a lot. Regardless, while we're waiting for that, we need to get this compiled on Android. So we'll do release. We'll let this configure and build. You know, instead of waiting for this, I bet I could just edit my pull request. Docker file. How do I... There's gotta be a way to do this. Edit file. Okay, let's just copy what I have here. Paste it with what I have here. Okay, commit the change. AI auto commit message. So awesome. I hate trying to come up with commit messages. Okay, so that got committed, so we should probably see the builds kick off again. So we'll let that run while we're waiting for that. We're still waiting for this to compile, which will take a little bit longer because we're in a dev container with WSL. Trying to think if I have a way to get, if I manage to get an APK built today to get Hello Triangle on my phone. I think I have a way. I think I can use my controller's USB, my game controller's USB-C. Preload's compiling. Let's take a look at our pipelines. Hopefully Linux is... Okay, the Linux Docker... Wow, was it that quick? I guess it only had to build the one layer, didn't it? All the other layers were already built. Yeah, that makes sense. I don't know about you, my one viewer, but streaming and talking to myself is exhausting. Especially when you didn't get any sleep because you stayed up until 5 in the morning trying to get these pipelines to work just for you to break them again. Not you. Me, you. Let's see here. Linux is still failing. Linux should be one of the easier ones to get right. What am I doing wrong? Still saying... Alright, I'm not going to use the pipeline to figure that out. We'll use our dev containers to figure that out. Alright, so Android's failing like we knew. So we got to figure out what's going on in here. Found the raylib. Can't find GLFW. Which I think makes sense, because I don't think GLFW is supported on Android. Like, if I come into this build... Yeah, there's raylib, there's no GLFW. So the issue is actually that I think our project is looking for GLFW. So where is that? That is in app. So yeah, we are looking for GLFW, but we're on Android. So we need to... We only want to link against GLFW when we are not Android and not WebAssembly. So now I'm hoping CMake has something versus just doing a string comparison. So what I'm gonna do is ask AI. GLFW is not supported on Android nor WebAssembly /mscripton. And mscripton is the compiler wrapper for WebAssembly over at GCC. GLFW is not supported on Android nor WebAssembly /mscripton. I don't know how to spell it. Mscripton. But my Awen CMake list tries to find and link against GLFW. Is there a way to do this such that GLFW is not looked for on these platforms? If not Android, not mscripton. That seems suspicious. Well, I mean, I can do MSVC, so, I mean, we can try it. Doesn't hurt to try. Oh my god. I get what it's trying to do, but, like, if you're some random person that comes along and looks at CMake file and sees this voodoo, like, there's a cleaner, easier way to achieve this effect, right? Can't we just do... Maybe it's just me, but it feels like this is significantly easier to parse and understand. Raylib depends on GLFW, so we need to actually list raylib first for static dependencies. That assumes this works. If not, I might have to define these values in presets. So AI could just be making that up. So let's configure, see what happens. Where's my cat? Did I leave him out in the garage? Well, this is building. Let me go make sure I didn't leave him out in the garage. Garage. Did not, in fact, leave my cat out in the garage. Alright, so that configured, which I think is better than before, right? So let's compile. Oh my god. Look at all this. Okay, we are getting somewhere. So this is telling me we need to link against Android's OpenGL libraries, I'm guessing. Which might literally just be target link library OpenGL. Or the dev container I'm in, which is for Android, needs the OpenGL drivers installed. So I don't think I really installed anything. I installed a couple of tools. That was it. So what I'm going to do, because I'm lazy, just grab a couple of these, toss in AI, and let it know that I didn't install any OpenGL packages. I'm trying to use Raylib in this Android dev container. I did not install any OpenGL drivers or packages, and I am getting the following errors. Like, AI is... Ooh, oh no, did I run out of money? AI can be very useful when you understand what problems you're running into, because then you can just like, hey, you get to guide it and tell it exactly what to look for. Please, all right, it's switched over to GPT-4 versus Claude, which GPT-4 isn't going to be as good, but should be good enough. At least for what I'm doing. To add the correct Android, yes, please fix Awen/cmakelist.txt. So the Android NDK then must come with the libraries I need, which makes sense. I mean, we're literally building this for Android. We just need to tell the project to link against those libraries. So it should have made some changes. Find library, loglib, Android lib, GLES v2 lib, EGL lib, EGL. Sure. I have not done this before, so I'm just going to assume ChatGPT 4.1 knows what it's talking about. And it's going to compile and run. Well, it's not going to run, but it's going to compile first try. If this builds an APK, though, watch out. I will throw this on my phone and risk bricking it. It compiled. I mean, I have to try. I have to try. Hang on. There's no reason to show. Because I built this for ARM, and I'm on an x86 platform. So there's no way this works unless I screwed something up. Yeah, so I cannot execute binary file, execute format error. That makes sense. Completely different architectures. So this is built for ARM. We have an executable, but it's not an APK. So now I need to figure out how to make this an APK. And I just lost my smart AI, so I'm gonna have to Google this myself or bump up my budget. Oh, I've used up so much money for AI this month, mostly for work. I'm hoping that CMake can do some of this work for me through the install bundle to make the APK, but my guess is I do have to get like Gradle and that Android manifest XML file figured out. I guess we can Google real quick. How do I generate an APK using Android NDK and CMake? Ooh, Android Studio has some documentation. Well, I look at documentation when you can use AI. Method using Android Studio recommended. Oh. This method leverages the existing Gradle build system. Ooh, do I have Gradle? If I do, it's not in my path. Create a project with C++ support. Oh no, I'm not using Android Studio. Here we go. Configure CMake. Build logic and CMake list file. Ooh, see, it is saying use shared there. But that, again, that's just freaking, you know, AI. What does AI know? I mean, we're doing this. Build the APK. In Android Studio, select build. I don't have the Android Studio. Command line. CMake system name, that's being taken care of. NDK is taken care of. Android platform is taken care of. Architecture ABI is taken care of. Toolchain file is taken care of. Make manually assemble the APK use. Wait, are they saying this should work? Pretty sure I'm using the toolchain file. CMake presets. Target. Android. Host. It's gotta be target. ARM Android. Uh-oh. Maybe that's... Wait. Platform. No. Compiler. Compiler Android. There we go. Yeah, I'm using the toolchain file. There's its compiler flags. Because it uses Clang. That toolchain file should set everything up. I wonder if it's a different build target versus install. I wonder if I need... Well, if it is, it didn't get auto-generated. Not seeing it here. Right? Guess I gotta have to read documentation like the good old days. Install, configure the NDK, install NDK and CMake automatically. Android Gradle plugin can automatically install the required NDK and CMake the first time you build your project if their licenses have been accepted in advance. If you've already read and agreed to the license terms, then you can pre-accept the licenses in scripts with the following command. I don't think I did this. I did not do this. I've done this before. I've literally done this before. Let me check my GitLab. Maybe I did it there. I spent a lot of time and effort getting this up and running in the past, but I don't know if I still have it. Because I even set it up to run a Android emulator out of WSL with graphics on Windows. some of this stuff was handled for me. This uses an Android build image I created a year or two ago. So where did that go? Images, Android build. Okay, let's see what this Docker file looks like. Oh my gosh. Significantly more involved than what my dev container is doing. Now, to be fair, I think this dev container was generated via some AI. But yeah, this, I think I need to do more. This is not enough. Before I mess with this, I should probably just make sure this is what I need to do. So this grab, oh, hi Trail. What are you doing? What are you doing? Ow, don't bite my foot. Ow, hey. Okay, so that grabs the Android NDK, which is what I do. But it also grabs the SDK, which I don't do. So we need, okay, yeah, there's a lot more I need to do here that I have to do. I'm going to put all this on. VS Code's commands work, and by the time I figure it out, here we go. It auto add more pages. Okay. So that's the NDK. I need to get the SDK installed. I also need to install OpenJDK. I don't know which version of JDK I need. Does the documentation tell us here? JDK. How do I find out what version of JDK? Okay. To use the SDK, I need to find out what version of the JDK is so that the NDK will work as expected. What is my cat doing? Hey, what are you doing? What JDK version does Android require? Android SDK require. Okay, here we go. Looks like we're still on 17, which is what I was using. Did I see that right? 17. For example, the Android Gradle plugin version 8 requires JDK 17. If you try to run a Gradle build that uses it with an earlier version of JDK, it will report a message. Current JDK, okay, so 17. That's what I need. Let's go ahead and install that. I guess I'll just install it with the tools. The build essentials, if you will, for Android. Now we need the SDK. Now, I'll show you what my old file has, but this was from like... Yeah, this is 2 years ago. Tells you how long ago this was I attempted this. This is almost certainly out of date. So how do I find this? Command line tools, Android command line tools. Android Studio command line tools. Gotta be a Google download somewhere here. Grab the command line tools. Ah, oh no, I was just here. SDK Manager. You can download the command line tools package. Here we go. Here we go. Our dev container is Linux, so this is what we want. Yep. I have read. And then here, I'll copy the link address. Boom. Boom. All right. Now we have the Android SDK, or the NDK, which requires the JDK. So it's the SDK for the NDK that requires the JDK. Remember that. SDK, NDK, JDK. JK. SDK, NDK, build tools. Okay, so now we have to use all of this to acquire the build tools through the SDK manager. So the SDK for the NDK that requires the JDK to get the SDK manager to get the build tools. And so I'll copy this. Again, this is 2 years ago, so I don't know. I think we're on newer versions of Androids, obviously. Android NDK. What is my cat doing? Hey, what are you doing? You not have food? Oh, now you're just flopping and rolling. Oh, man. Let's see here. SDK. NDK, JDK. This is Android 34, Build Tools 34. But I think, what are my presets set to? I probably want to be using the same thing. Am I using like 28? Am I using an Android Studio? This is what I use on for Flutter. Android 16 API level 36.1. I don't know enough to know if I should do like, does that mean this needs to be 36.1 and this needs to be 36? Is that even a thing? Let's see if they give us documentation. No documentation here, at least. Oh, it wasn't the download section. Dang it. Thought it was. So we want to look at the SDK manager. Okay, so Android 36, I was right about that. Build Tools 36.0. Does that give me the latest build tools? I don't know. But Android's website says 36 for both, so that's what I'm going to do. Platform tools, I think, gets us the emulator, which is kind of cool. It'll be cool, actually, if I can get that up and running too, that would be sick. This is the whole say yes to the licenses, so that's good. Android SDK, am I actually extracting it here? I am, that's good. SDK manager, say yes to the licenses, give us Android 36 platform, which tells me I probably want my target to be 36 as well. I think that's reasonable. Even if I use an emulator, I'd have to emulate ARM. Ooh, this is gonna be crazy. If I can get Hello World Triangle to work, I might call it there, and then go to that bonfire. Let's see. Where was I? Dockerfile. Lost track of my thought. Wrong Dockerfile. Let's close out that one. Okay. So it also is doing this, but I don't know if I need all this. So Java Home, that makes sense, except I'll set that up here where I define the Java installation. I don't know what the best way to do that is, because you kind of want to do Docker files in layers, so if you have to modify a layer, you're not impacting the other layers, versus setting all, all your environments at the end just because it's a little more readable. Android NDK. No, stop. Okay. Now my NDK is 29. R29, I think. R29. Is that right? R29. And I can actually figure that out because I'm in the dev container. Huh. That's awkward. Did I not? Where did I put that? I think I like this better. So if I do /opt, yeah, I think I prefer having it at the root. I'm not using this container for anything, so I'm gonna change that. I think I do like this. So we'll do this. This needs to get moved. This here. Set the environment after DK version. That makes sense. This does not make sense. That doesn't make sense. Can I do... allowed? I don't know if that's allowed or not. We'll find out. Android NDK home, so that got set. I don't need that. The Android, gosh, the Android, oh, come on. The Android SDK got set here. Yeah, I kind of like having the environment paired with whatever it needs, or whatever we're specifying here, because then I can easily look. I want to be consistent. We're using equal everywhere. We're not using equal here. You know what? I like it without equal, I guess. Equal makes sense to me. Let's do equal. I don't know which way is better. At least here you're seeing that you're assigning something. Path equal, 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 and we're using equal for other stuff. Okay. So that sets up the NDK home, the Android home, the SDK here. What else do I need? Is that everything I need? That might be everything I need. So now, We need to rebuild this container. Dang it. Choking on a crumb. So this will go out and grab all the different SDKs, NDKs, and JDKs. All the Ks, honestly. I can get this to work. I think I remember how to get an emulator up and running. And then we can toss hello triangle there. I'll also be able to, if I can get an APK built, I can just drop it on my Android phone and see what happens. I've had issues in the past though where like only debug will run. I've only successfully ran a release build on Android through Flutter, so clearly I've screwed stuff up in the past. I just don't know what I'm doing. Downloading all the Android. Yeah, I don't know what to do here. So I'm trying to, with a couple of colleagues that used to work for me, trying to build a game. I want to show off building that game while streaming. But I also really like tinkering and building game engines that never see the light of day, because then I get to learn stuff like this. Using Godot has been interesting with our game, but I kind of wonder how much effort it would take to get this up to a state where we're making use of Godot. So Godot, we're mainly just doing like, we're using it for rendering and input handling for the most part. We're not using it for our game logic, our data management, or anything like that. That's all C++ backend. So that would be transferable. It's only the graphics rendering piece that we would need out of this if I wanted to keep building this up. I'll be honest, Godot's kind of a pain. I think any game engine that requires a heavy use of the editor is kind of a pain from a workflow perspective, just because I'm so used to bouncing around files and writing functions and stuff like that in an editor or an IDE or a text editor or an IDE. Whereas with something like Godot, I gotta kind of hunt and peck to modify values, add nodes, drag and drop nodes to track references, that kind of thing. It's just, it's a little, I'm showing my boomer side. It's too new. I have my way of doing development, and I want to continue doing my way of doing development, and Godot is pushing against that. Also, Godot doesn't use CMake for some reason, which kind of blows my mind for such a popular engine. CMake just works with everything, and they use scones, SCONs. I don't know. Clearly, it does the trick. And I might be biased. I've been using CMake my entire professional career. Okay, it says I need to rebuild. Oh, so I might rebuild again, but it shouldn't have to since everything was already just built. So let's do it again one more time, just to fix whatever issue VS Code sees. Maybe I forgot to save the file or something. Okay, this is gonna get annoying. It keeps asking to rebuild. Okay, whatever. All right, let's get a normal terminal going. Okay, So now we actually have the SDK, the NDK. So if we look, the JDK, there they are. Cool. I probably need to I'm gonna delete my build. See what happens. I'll just configure it. I'm hoping with all of that in place, I configure CMake, I build, and it automatically creates an APK. Oh no. Oh no. Could not find the Android NDK. Search that / Android NDK R29. I hate programming. I'm gonna do something here. Oh, while I wait for that to come into place, see if I can figure this out. Usually when something like this is happening, it's because it can't figure out find stuff. So it's not resolving Android NDK anymore. Whereas it was before. Did I define the environment variables wrong? Maybe I'm not supposed to have an equal sign here. Or maybe I'm not supposed to have quotes here. No, that should be fine. It's in the path. Let me see. It's right there. Android NDK is in the path. The other thing I was questioning was if this worked, but clearly it does because it exists in the container. Android NDK home. Let's look at the environment variables. It's right there. Android NDK home is right there. So the other thing that happens here a lot of the times is VC package will start with a somewhat clean environment, so it won't pull all this stuff in. Which, you know, good intentions and all is a pain in the butt. But that can cause things like my Android NDK home environment variable to not resolve. And if it doesn't resolve, we get here. Looking for it on Windows. If defined, set it. Otherwise, look for it only on Windows. So the Android NDK variable is not getting defined. So my guess is this Android NDK home environment variable is not getting passed into VC package. So when I configure, it fails. So I have done this before, and I think this required a custom triplet in order for me to get the variable to pass through. So I gotta track that down. Yep, it's right here. So I've passed in the Android home environment variable before. Android NDK home. Because I had to define the SDK root. So if we look at the current Android triplet, let's see what that looks like. VC package, triplet. Actually, which one am I using? ARM64 Android release. CMake system version 28. This might be part of the problem if I'm having a mismatch. No, that shouldn't be it. Why did this work? I wonder. Okay, let's try something else before I create my own triplet. I really don't want to create my own triplet. I really like to. I mean, I keep saying this. I really like to not write my own custom CMake scripts if I can avoid it. Just use what's there, because then it's a lot less for anyone else to go in and like figure out what these functions do and why they exist. And you know, someone with knowledge comes in and goes like, "Oh, why'd you do this? You could have just done this, right?" So I really like to lessen the burden there when doing development like this. So let's try to put this back into /opt. See what that will do. Maybe VC package can automatically find it in /opt, whereas it wasn't getting auto found. I moved its location. That's kind of my hope. Well, I need to do that for the SDK as well. Should I just do that? You know what? If I'm just going to rebuild this, I might as well do it now. /opt Android SDK. This auto stuff that AI does where it auto like completes your relations. Things that are relative to each other. It's so nice. Saves me so much time. So it was /opt /android /ndk, then the Android NDK path. I guess let's do that. /opt /android /ndk /android ndk. So that means I can put the SDK in under /opt /android. So /opt /android /SDK. I don't know. I hope this was the issue. That's all I got. So I'm gonna try something a little different. I'm gonna reopen folder locally. that's the changes I made remotely. And let's reopen in container. Oh, it's probably not going to build it. Android. Hope it builds it. Yeah, I didn't build it. So I'm going to let that finish running. One thing that's annoying about VS Code that I've never liked about VS Code is all of the pop-ups that will pop up while you are in the middle of frickin' trying to deal with a pop-up. Build container. Maybe I should explore different text editors. I used to use Sublime Text a lot. But at one point for work, I didn't really have a choice. We all just had to use VS Code. So I kind of just got used to it, even though it's like really slow and a pain in the butt to deal with sometimes. But the dev container stuff, the integrations with the extensions, it's hard to beat. If there are other editors that would also do all of this for me, then, you know, it's probably the way I'd want to go. Alright, so now the container's busted. Ugh. It's never easy. I just want to render a triangle on my Android phone. Is that too hard to ask? You know, sometimes I get it. I see where people are like, hey, you know, C++ is complex and difficult. And they're not wrong. I just want to render a triangle on my phone. Okay, so what's going on here? We failed to download? Failed to build. Looks like, yeah, it looks like it's failing to extract. Did I screw up the Did I screw this up? Does the directory have to exist? Did I... Command failed. Did not complete successfully. You know what? I'm gonna see if my AI came back. I'm just gonna give it some of this. Some of this. Oh, I mean, the error's right here. Never mind. Cannot create extraction directory. No such file or directory. Opt Android SDK. So why does that not work, but this was working? So I think the solution is I have to do something like that. Let's try that. I'll tell you, viewer, if you're an actual viewer right now, and you've been hanging out with me this whole time, I'm impressed. But trust me, I will get a damn triangle rendering on an Android phone, I promise. Maybe. Ish. Sir Elfman, we got someone. You are the first person to ever message me, ever. So when I become big and famous, you will be the one chatter that I will remember. And I can't tell if you're like asking if I'm really a C++ veteran or if you're making fun of me because of my struggles. To be fair, we haven't written that much C++ yet. This is all pipeline automation maintenance crap, which will make my life easier down the road. What is my cat doing? I guess I could actually like see what the Docker file has been. All right, I mean that's promising. All right, paint's drying. I'm gonna go fill up my cup for some water. Be right back. All right, what do you want? What are you doing? Why are you scratching my rug? I tossed my cat out the garage so he can stop scratching up my rug. To be fair, it's really nice out there and he likes to chill and relax. Alright, we're back in the container. Alright, so I have already forgotten what my original issue was. It was the fact that the Android NDK home environment variable wasn't getting past a VC package. So we will try this again and see if that solved the problem. Not hopeful. Immediately not hopeful. Oh wait. The fact that it resolved this is kind of huge, isn't it? That means it's looking for it. So I can just opt Android NDK. Oh, whoops. Ha! It's Android NDK, so that's why it can't... Okay, so the SDK for the NDK that requires the JDK has accidentally had another NDK created within an NDK. Alright, so I needed to... When I unzip my NDK folder, which internally already contains this... I think I just do... that? Yeah? Yeah? Right? So we make this directory. This zip already contains the Android NDK 29. So we zip it into here. Let's try it. So close. So close. But if you know anything about developers and their estimates, whatever they say, double it. I don't know what double of so close is though. So let's just say I'm Really close. Okay, what's going on here? Usually there's a little pop-up letting us know what's getting built. VS Code dying on me? I am assuming something's happened, but I'm not even seeing... How long do we let this go for before we decide to try, reset this and do it again? I hate for you guys. I hate for my one viewer to have to sit here and watch a gray display. Can't do it. I don't trust it. I tried. Look, I tried. Alright, so we're gonna reopen. And we'll rebuild. So at least we'll feel good when we see some lines scrolling by. Reopening container. Android. Okay. I was starting to panic. Okay. It's time to... At least we can watch the paint dry. That's what's important. Sir Elfman. I'll be honest, I didn't think I would get a someone chatting for years. Is there a way I can look you up? I want to know what you're about. I am curious. You a bot? There's no way you're a bot, because you exclaim C++ veteran. Look, you can't make fun of my C++ skills. I haven't written any C++ on stream today. Is that true? No, that's true. The only C++ written was by AI. And that was for that triangle. Alright. What is going on here? Exporting layers. How's my computer doing with all this compilation? You know what? I didn't even think about that. Compilation, encoding. How are we looking here? Only 30 gigs used? Only a handful of my cores running? That's good. Ooh, my GPU is cooking. Well, okay, the video encoding processor is cooking. The actual 3D graphics is idle. Wants me to rebuild again. I don't trust it. Alright, so let's see if I actually got the NDK in the right spot this time. Android NDK. There we go. Okay. Whew. Configure. Please, please, please. Just work for once. Just once. Android 36 is above the maximum supported version of 35. API level, choose a supported API level or set Android platform to latest. Maybe I'll just say latest. Please work. Please. Please work. This is an easy fix. That's interesting. Because I swear, in Android Studio, which I haven't updated on my computer in a minute. Yeah, 2025. I'm using API level 36. That might not be the platform. I'll I'll be honest, I haven't read up on what all the differences are. So that might just be the platform or the API level. Huh. These work. I mean, dependencies are compiling. So that's good. But the important thing is going to be when I build Awen, it creates an APK. Or it at least gives me the pieces I need to create an APK via like Gradle or whatever. Does Raylib use STB? I've used these headers before for work. Pretty good headers. I do like that things are compiling. Okay, so why is it always after I say I like something's working? Hopefully this is the issue. Oh, this might be the issue. This is easy to fix. I can fix this. I just need to set Android platform to latest. What is that? Target, Android. I'll just do latest. Because here at Fun and Software, we're always working with the latest. Or better or worse. Alright, let's try it again. Configure. Ooh. Who's setting this? Android 36 is above... What's going on? I might have to clean my CMake cache, to be fair. Because it almost... Actually, yeah, now that I think about it, almost certainly. And I changed a preset, so it might even require reloading the window because VS Code doesn't actually use these presets, it parses them. Clean all projects. Oh my gosh. It failed to clean? How's that possible? I think it rebuilt. Okay, so here's what I'm gonna do. I'm just gonna nuke the build directory. Easy enough. Delete. Nuked. Alright. Alright. Pause. So I can record an awesome video. This is where I'll start. First try. Don't say anything. It didn't work. Someone's setting that. Where am I setting that? Android platform. Alright. Instead of debugging this myself, I'm going to have AI debug it to see if it can come up with something. I mean, I'll still try, but it might be able to do it quick. Oh, it's already done. The NDK R29 Legacy toolchain resolves latest to Android 36, but then rejects it since the Legacy toolchain only supports up to API 35. So is the actual issue that I'm using a Legacy toolchain? Maybe there's a new way to use Android that I don't know about? That's the compiler, right? Is this like a legacy toolchain? I mean, this is the only way I know how to do it. This is what I was doing 2 years ago. Alright, well, we'll see if that's the actual issue. If that's the issue, then, you know, I'll take it, because I kind of want to move on. It wasn't. Let's look at this. Something else is setting it. Is it VC Package? It can't be VC Package, right? Because I'm using the Android triplet from VC Package. I'm using ARM64 Android release. This just sets CMake system version. Maybe I need to drop an NDK version down. I am using the latest Android NDK versus the latest stable Android NDK. So that might be causing headaches too. We'll give AI another shot at this. I'll make sure I tell the AI that the problem is still happening. The problem is still happening. I even deleted the build directory and regenerated everything fresh. Because otherwise it might go like, oh, we see your build directory is stale. Let's rebuild. I'm like, I just did that, dude. I wonder if... Oh, wait a minute. Is this also the issue? But didn't Android documentation literally say to do that? For example. And even in Android Studio, I'm using version 36 API 36.1. I wish I knew where, like, I don't know, the official value to use is. Platform tools. Alright, let's see if AI can do its thing. It's digging into the Android NDK now. I don't know if anyone can see. I'm just gonna let it go. Enable auto improve. Watch, this is where it just deletes everything. It breaks out of the container, grabs control of the stream. Then who knows where it goes from there. Oh my god, it's getting deep into the NDK. There is nothing that can hide from this. Now it's looking at the try-compile CMake file that was failing. Let's trace what's happening. It's looking at the CMake system versions. I'm sure it's a flag or something I'm not setting. Like I said, the last time I did this, and I was successful, I had to write my own custom triplet. But I'm already further than before, and that's because I put everything in that /op directory, which I didn't realize VC package looked there. Okay, so what's happening here? Let me verify the preset change was saved. Oh, you know what? I said this. I might need to reload the VS Code window. Because frickin' VS Code and CMake presets, VS Code does not use CMake presets as a preset. And I guess this is documented. I only know this because I went into like GitHub to look up issues about this. And I guess this is like, I don't know if it's intended or if it's a bug, but like Kitware, the people who make CMake literally have said like, hey, if you're going to use presets in editors like this, like VS Code, you can't actually use the preset. You have to parse all the JSON files and generate the CMake flags yourself. So sometimes if VS Code fails to catch that the presets have changed and needs to reparse the files, then I have to reload the window. Maybe that's the issue. But I don't want to reload the window while the AI is running. So maybe it will determine that's the issue as well. Okay, yeah, so it is saying that the CMake, I guess, yeah, we could also look too, right? So the way CMake works, any variables that do get set, they get set here. Yeah, look. So the cache is still saying Android 36. So that almost certainly means I might be right. So before AI gets any further, let's verify I'm right. So we'll delete this. And we need to reload the window so that it can reparse the JSON files. Oh, session in progress. Are you sure you want to reload? The session will stop if you reload the window. Yes. And what we should see is scrolling text at some point of the preset files getting parsed. Oh yeah. Almost like I have done this before. All right. So now, maybe, hopefully, I can configure. This doesn't work. I'm gonna flip a table. I actually can't. This table's super heavy. It's like made of steel. I'm not seeing the warning anymore. Found Raylib. We did it, guys. We configured the project. Shit. Oh my gosh. Okay. So now that we know it configures, I do want to just set this to latest so I can set it and forget. No, it works. No, don't mess, Aaron. Don't mess. All right, let's just build this. Let's get this over with. Compile, please. 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 It compiled. Okay, it compiled. It did not make an APK, though. So now we're back to where we started before we went through all of this. Checking to see if maybe something was done for me, maybe. All right, so now I need to figure out how to build an APK. You know what? Let's stage changes before I let AI do its thing. I don't want to lose any changes we've made so far because we finally did get this working. Configuring and compiling again. And then I might just say, hey, AI, configure my project to build an APK. Surely it can do that. All the pieces should be there, right? The NDK, the SDK for the NDK that requires the JDK, it's all there. This is taking a minute. That's why it's taking. I'm going to reopen this locally so I can actually get stuff committed. Let's take a look at what we've changed. All right, so for Android, we added the SDK, we added the JDK, we updated the location of the NDK. So now everything appears in /opt Android in my container. For Linux, we fixed the packages that needed to be installed, so that should hopefully fix the build errors we were seeing on Linux. For Awen, we added the additional libraries we need for OpenGL on Android. So that's it's finding packages, I'm assuming, inside the NDK. I'm sure we can figure out exactly what those are. Actually, we could, because we could just look at the compile commands.json file and see what it's linking against. And then if we're not Android or in Scriptum, WebAssembly, then we are using GLFW. Well, Raylib is using GLFW to create the window. And then if we are on Windows, as per Microsoft's or the MSVC compiler's warning, we needed to turn this flag on for debug. And then also on Windows, GLFW depends on the Windows API for some kind of timer code. We set this to 35. That's good. So update. Ooh. I made a change. So I need to stash. Forgot I made a change in GitHub. Pull that change down. Then I need to pop the stash. There we go. Push that up. Okay. Get this back into the container for Android. And while that's loading, we can take a look at our pipelines again. See if the Linux stuff at least. Oh, come on, dude. This is on me. I should have tried to make sure it built before I pushed it up. It doesn't like the... Okay. We're just going to hop into... Alright, I'm going to fix the Linux Docker file and then... Oh, what the heck? I didn't realize there was a merge conflict. I got. Are they the exact same? They are the exact same, so let's accept the change. Alright, so before I do anything else, let's open up the Linux container and make sure it builds. Looks like it's building, so that's good. Exporting to image, all that looks good. So the container's starting up, that looks good. keep getting sidetracked. You see how every little thing that needs fixed will take you down another road? It's like that, it's like the, that Malcolm in the Middle, intro scene to one of their episodes where Hal is just like, he goes to fix something. Oh, but he needs a screwdriver to fix it. Oh, the screwdriver's in the drawer. He goes to pull the drawer open, but the drawer is like loose, so now he needs to fix the drawer. He goes to fix the drawer, but he can't see, so he needs a light. He goes to grab a light, but doesn't have a battery or something. Then he goes out into the garage. Like, oh, it was hilarious. It's like the hole in the bucket, Dear Liza song. Okay, so now that I'm in the Linux container, before I leave, let's just make sure it configures. Let's just do GCC release. Honestly, while I'm in the container, I can also run the Hello Triangle and make sure that I get a graphics window, which is kind of cool because it's running in Linux in a container, but I get to see graphics on Windows. Pretty cool. I think it's cool. So I remember the days where you never got to do that. This has made productivity so much easier. Being productive so much easier. Caesar building right now. Come on, work. I think this is where it was failing last time. Because GLFW needs X11. I guess that could technically be a downside for using Raylib also, is if Raylib isn't supporting the latest Wayland windowing system. Maybe it does, and VC Package just didn't configure it to compile with it. Or maybe I need to set a setting, I'm not 100% sure. I think long-term, SDL might be the way to go, because it is a little more low level, so I'll have a little bit more flexibility to do my own implementations, especially for things like batch rendering, deferred rendering kind of thing. But at the same time, I'm doing 2D, so it's not like I need that kind of implementation for performance. But like, if I could just say, hey, AI, implement a batch render or implement deferred rendering, it just does it. It's not a lot of effort off my end. I just do the code review at that point. That's the cool thing about AI. It's like having my own team who understands better what I want from a solution, and if they get it wrong, I can correct them really quickly. Versus like, you think about a junior dev, I assign them work, and they go off for a couple of days, or even just a day or half a day. They go off and get work done, and then I come and check up on them. I'm in meetings all day, so it's not like I'm just sitting over their shoulder. I do want them to try and figure stuff out on their own. But I go off and do my own thing and come back, and then it's like 4 or 8 hours later, and it's like, oh man, that is not what I wanted at all. So now I got to go and spend more time making sure my team understands the context, understands how I want them to write code. So it's a lot of time spent training and everything, which is perfectly fine because that is what the job is when you're leading a team. But with AI, I just like say, hey, you got it wrong. You're like, okay, and they swap it real quick. I don't have to explain or anything. But the downside of that is I don't get to do any of the explaining, which is kind of what I've enjoyed in my career, was helping other people grow and learn. Which is kind of where I'm coming from for streaming for the first time ever. I've had an eye on streaming forever. I just never knew what to do because you guys know it's everyone and their brother has basically hit up all the niche corners of streaming, and there's going to be much more entertaining people out in the world. And I kind of just want to experiment, try new things, and maybe get an opportunity to share some knowledge. And, you know, if that doesn't work out, I'll just go play some Rocket League. All right. Cool. So that configured. Let's compile. It built. All right. All right. Here's another first try moment. I think I'm 0 for like 10 on first tries. What did I do this on? Release, installed, bin. Oh, look at that. That is my application. Obviously, it's a little slow, but my application running in a Docker container inside WSL Ubuntu on my Windows desktop with graphics. I love that. That is so cool. And if you're ever curious how that stuff works, I think under the hood, and the reason why that you're seeing it be like slow, other than the fact that like I'm rendering within a container within WSL, is these windows that you can resize that we're seeing. It's basically like a lightweight Windows remote desktop that is like wrapped around the application inside the Linux environment, which is how we're able to see this stuff. But it is kind of cool. So I kind of want to do the same thing with Android. So that's what I've been trying to get towards. But I keep getting sidetracked by other things that are broken. Okay, so now we know the Linux container is working. Reopen folder locally. We can get this pushed up. Finally. Alright. That first try counts. Let's see here. What did I change? I fix invalid fix merge conflict that did not get resolved. Yeah, there we go. Let's push that up. Okay. So now we can get back into that Android container. Much as I don't want to go back in there. So we got to figure out how to build an APK. And then we can also check our pipelines. Maybe the Linux pipeline won't fail immediately this time, please. Please. Don't fail immediately. Alright. We're back in our Android pipeline. Let's make sure we can still build. What was I building before? Was it release? Release. Make sure that's still built and in a good state. And then I think I'm just gonna have AI let loose and figure it out for me. I like sure I can figure it out. It's just reading documentation. That's why I pay the AI, so I don't have to do it. I am getting hungry. I haven't eaten since the beginning of this stream. I haven't eaten much. Having not streamed before, this and having to like keep voicing my thoughts aloud, not knowing if anyone's actually watching or not, a little stressful. And makes me ravenous. Let's see. Configure, generating done. Let's compile. Alright, so that built. So that's good. So I think we're in a good spot. So now it's time to let the AI loose on the project. I like to open up the file I expect it to touch so that it has a little bit extra context with what I'm expecting it to do. So that's going to be the CMake list file. When I build Awen, I need to create an Android APK. I'm in a dev container with the SDK and NDK. I am also utilizing VC package. I feel like VC package has a way to do this. I don't remember. See, the problem is I've used Qt in the past, and Qt has always been who handled all the behind-the-scenes packaging. That's usually what produced the APK, but because I'm not using Qt now, I kind of have to do it myself. I'm in a dev container with the SDK and NDK. I'm also utilizing VC package. How do I go about generating this APK using the available tools? Something like that. Let's see what it does. Ooh, okay, so I might actually need Gradle if I don't have Gradle. So I'm going to set this to just go ham. Allow all commands in this session, so if my stream ends, you'll know why. The AI took over. And then I'm going to go heat up a burger real quick. Be right back. Also, I need to get my cat out. It's chilling in a box he found in my garage. Let's see what the AI is doing. The AI is still cooking. Oh my gosh. I thought it would be a lot easier than that. Oh, what is it even doing? SDK detail. Okay, so it's grabbing the state of the SDK. It found what the state is. Look, Android 36. Whatever. It grabbed the state of the NDK, the job. Okay, so it's trying to find all the tools it needs. It looks like it doesn't have Gradle, so I'm guessing I'm going to have to get Gradle installed. Well, I mean, AI is going to install it for me. Yeah, look, you can kind of see what it's processing. And then I think there will be some config that goes into the Gradle, and if it's something I have to manually write, then I can probably get CMake to auto-generate for us. It's still running. Oh. Maybe I should have used Opus. Opus is a little better at... supposed to be better at digging through big hierarchies versus just like writing a block of code. Oh, something's happening. Spicy black bean burger. There's the Android manifest file I was expecting. Okay, this makes sense, I think. We build our application as a library for the Android runtime to load. Because I think eventually, most of the code for the engine is going to live as a library anyway. Main is just going to be there to pick it on. So realistically, if we build for Android, we don't even need the executable at all, or the project for the executable. We just use the core library or something like that. Okay, so it looks like it had to download Gradle. Nothing. So, if any security expert ends up watching a clip or a video of this, ignore this line. That was basically the AI downloading a script from the internet or creating one, giving it executable permission, and then running it without me ever knowing what was inside of it. No one saw that. Before publishing to the Play Store, replace signing config with a proper release store. Oh, cool. Okay, so we got something. How to generate the APK. CMake list now builds lib Awen on Android. Native activity requires an SO entry point. I knew Android needed it as a shared object. I knew it. Raylib bridges Android main and main internally, so your existing main is unchanged. Interesting. A standard Android Gradle project wrapping the native build. I have an Android directory with a setup script, Gradle W wrapper script, my settings.gradle.kts, build.gradle.kts, root declares AGP. I don't know what AGP is. Android Gradle project. Gradle wrapper properties. Then there's an app folder, build Gradle, external native build CMake VC package. Okay. Source main Android manifest. Okay. One-time setup. Downloads Gradle wrapper jar, writes local properties. Oh, okay. So this one-time setup thing, I think we can just... I'll have to see what this is doing. I'm hoping I can just bake this into the dev container so that I don't have to, like, have scripts lying around in my repo. I never like requiring developers that use my repo to have to get up and running in more than like 1 or 2 steps. So having extra like scripts that have to be ran, that's usually a no-go for me, so I always try and find a way to avoid that. Debug the APK. Gradle W assemble debug. That's interesting. I've not done any APK debugging before. Install to a connected device / emulator. Oh, that's using ADB. That, yeah, I'm familiar with that. How do I actually build it? How the chain works? Gradle CMake with full chain file. PC package installs static raylib. We produce lib Awen. AGP packages it into APK with app2 APK signer. Okay. Before publishing to the Play Store, replace signing config. Okay. Okay. So what happens here? Do I just hit build? It created an SO. Didn't really say. Give me a new target? Do I have to manually do it? What is AGP? I might have to ask AI what's going on there. Oh my god. Look at all this. Okay. Runs a Java VM, it looks like. Entry point name. Hoping I can do away with this script. This makes me think I can. I have a hard-coded path that's dependent on my container. Like, this script would not work outside of my dev container. So I'm thinking all of this can just be added to the dev container. This kills me. I don't understand the difference between Android platform version, the SDK version. The API version. All right. That looks fine. That looks fine. So do I... Okay. So do I call Gradle? I built my shared object via my CMake preset, but it did not create an APK. What are my next steps to create an APK? Let's stage these in case the AI wants to overwrite anything. I want to install to a connected device. I want to create the APK. What's going on? Gradle does not use your CMake preset under my preset. AGP manages its own CMake invocation under Android app.cxx. I don't know what AGP is. Look, dude. I don't know what AGP is. I just want an APK. Make it happen. At a certain point, you just have to get fed up and just tell the API to do it. It just said it realized the build outputs an executable, not a shared object library. What? What? I honestly did not think AI would have to struggle this hard to tell me how to build an APK. I would assume that it would be straightforward. Maybe I'm wrong. Linux pipelines are still failing, so that's cool. Even though it passed, even though it works on my machine. So it just literally run like Gradle on the command line? Android Gradle plugin. AI couldn't tell me, so I had to do it myself, which is crap. Adding the Android Gradle plugin to your build file will register all the tasks necessary to build an APK or an Android library. The Java library plugin lets you build a jar from the Java source. Gradle prefers convention over configuration, so plugins will come with good default values out of the box. You can further configure the build through a declarative, domain-specific language. Even the documentation doesn't have a command line interface that says, hey, this is how it works. Gradle, demo release, input values, or something like that. It just says, hey, this is what's available. No examples. What's the next steps? Where do I see that? Next steps. Now that you've seen the build concepts, take a look at the build structure in your project. Okay. .gradle, cache directory, build files. It's so hard to get the actual instructions. Okay, so it the AI, instead of telling me how to do it or what the commands is, it created a script. So that I can, oh my god. Wall of text crits you for 300. Holy hell. Where'd it go? Alright, so repository root, manifest file, all that stuff gets set up. We have a debug key store that's going to define all the input parameters, I'm guessing. Build the project, which that's not how we are going to be building. We use CMake presets. Creates a directory. Compiles the resource directory. Which is strings.xml. Okay. Link the manifest and resources into a bare APK. Linking APK. AAPT2. This is crazy. Is that really how you have to do all this? I'm honestly about to look up the Qt open source project and see how they do it. I'm actually kind of surprised there isn't already something that exists to make an APK. 2013. 11 years ago. This is probably out of date. Android create APK. Bunch of custom commands. Yeah. Okay. Maybe this is what you're supposed to do. I mean, I've never done this before, so it's just surprising it's so many steps to build an APK. I would have assumed it would have been like, hey, build. Here's a bunch of input files. Here's where your entry point is. Here's where the Android or the APK input files are. The Gradle inputs. Build. But this is running a bunch of steps. Just like my script is. And I'm not finding the documentation on Android's website. Maybe this is it. I might have to spend a lot of time reading this and learning. This is actually kind of complicated. Someone else? CMake wrapper. Android packaging.cmake. That is somewhat up to date. 4 years ago. Looks like everyone has had to do this. Nothing that's being maintained. Ooh, 1.2k stars. 14 years ago. 12 years ago. No. Ugh. There's just no way it's stayed the same for the past 12 years. Does VC Package not do it? Let me ask. I'm gonna ask in multiple locations. I mean, VC Package is the package manager, so it actually would surprise me if it did build APKs. Saying to use Android Studio to build Gradle. I mean, if I need to use Android Studio to generate all the config files I need, I guess that would be okay. I was not prepared. I did not realize. I mean, I guess I can just try and run this script and see if it magically works. And then load it on my phone and see what happens. I don't know. I don't know how it will, if it will let it run without a key store, without something to sign this. All right. So how do I actually run the script? Did it tell us how? Build APK, configure, compile, package, into a debug APK, no Gradle required. No Gradle required, what? Alright, so from project root, run android build apk.sh. Alright. Let's see what happens. No, that's not good. Detecting compiler hash for triplet? That's not right. CMake preset. Then, no, hang on. This isn't right. This needs to be... I don't want to do it like this. I'm going to comment this out. I expect anyone using Awen to do everything through CMake build preset. I mean, technically you can do it however CMake lets you. That's fair. But I want to be consistent with everything in the repo. So this will build everything, including the target lib Awen. So it should be findable, except really what I want to do is do target install. So then in the build directory, which is defined as, yep, I want to find lib Awen in build/installed/lib, I think. So if we look, did it actually... Yeah, right here. So that's how I actually want this stuff to work. None of this involves Awen. Alright, let's try that. I'm okay with that. I'm not doing this. I don't want to mess with the ADB. I want to manually load it. Like a man. I want my executables running bare metal. Let's see here. See what happens. I mean, I looked at the script. If anyone's watching, you see the script too. I didn't see, I was about to say, I didn't see remove-rf/root, but to be fair, I don't know what out looks like. No, we're good. We're good. Woo! Nah, this is fine. That's fine. I'm not worried. I'm not worried. Man, if I have to use a script like this, that means I'm going to need to do some CMake work to CMakeify the script. So if I build the script up with CMake, then it can work technically cross-platform, not just in a shell. Something happened. Unsupported option, key alias. AI, man. But to be fair, I wouldn't be as far as I was without it. Key store key alias. Like I would have to have digged so far to find that, if that's true. Now rerun. Okay. I promise, at some point, probably not today, maybe not tomorrow, but at some point, I will write a line of C++. Getting this stuff done and out of the way will pay off. It will be glorious. So glorious. I did check on my cat. He's still chilling. He'll usually sit out in the garage for a few hours. Oh my god, what's this? APK ready. Awen debug.apk. Did I not build it as release? Or did I just build my library as release? Right? That's release. Woo! Let's do this. We're gonna first try this. Hello, Triangle. Straight to my phone. Oh, man. I'm sure this is fine. Okay. So, what I need to do... I'm not going to do ADV install. That's crazy. I'm just going to manually drag and drop and have Android install it for me. Where is this located? Workspaces, Awen, Android out. Android out. Awen, Android out. Oh, there it is. Debug APK. So let's copy that. Oh, let's make my phone allow files. Transfer files, Android Auto. Okay. Then we are going to drag and drop this APK into my phone's download folder. Yep, there it is. Okay. Alright, let's do this. Let's go to my download folder. Files. Downloads. Install app. Scan app. I didn't put a virus in there. We're good. App looks safe. Install. Installing app. Awen was installed. Come on. No whammies. Alright. This would be the ultimate first try, right? If this, like, worked. I'm gonna press. It crashed. It crashed. It was blocked. Oh no, notifications were blocked. It crashed. Dang it. Okay. So then... do I try this ADB install thing? Will that help me debug it? Wouldn't I have to, like... oh, I have an Android connected. Daemon not running, starting now. No devices emulators found. So I gotta get an emulator up and running. Which I've done before. I just gotta remember how I did it. I think I have it in GitLab somewhere. Okay, yeah, I've done it before. So I have to do... what do I have to do? Oh, but I might have to build the APK as a, x86. Oh, let's try it. Do I have SDK manager in my path? No. /opt SDK command tools. Then SDK manager. I need emulator. So should I make sure my dev container already has the emulator stuff built in? And if I need it for development testing, probably should. Okay, so then we do SDK manager. Except I want Android 30. See, this is where I don't know. Do I want 35 or 36? System images. We'll just do 36, whatever. Failed. Okay, let's try 35. Failed to find package, system images, Android 35, Google APIs, x86-64, ARM64 V8A. I mean, this was 2 years ago, so these commands might be out of date. Let's do it one at a time, see what it's failing. System images. Okay. That doesn't work either. Okay. I need to install the Android emulator so I can launch the debug session of my APK. Sure, let's do something like that. My knowledge and my notes are out of date. You know, again, I wonder if I built this in debug, maybe it would run. This sucks. Like, it's there. It's on my phone. Just not having it. Now it's not even. Yeah, okay. I'll just run it. To be honest, it wasn't the path I thought the stream was going to take today. Just trying to get. I really thought Android would be a little easier than this. EDB over Wi-Fi to a physical device or Android Studio on the host. If you have Android Studio installed on your host machine with an emulator already running, you can connect to it from inside the container. Okay, so let's do that. I can do that. Virtual Device Manager. I have an old Pixel 5 I like to test with. Let's run it. API 35. Okay. Alright, we have an Android window. Guess I'll move this off to the side. I don't think we need any of this. Oh, lost the window. Okay. Let's move this over here. Pixel is starting. Cool. Okay, so this is saying I should be able to connect to the device. So option 1, physical device recommended, works now. I have a physical device. Plug in an Android device with USB debugging enabled. Ooh, do I have that? No, it's been a minute. Not an Android developer. USB debugging enabled. If I was USB debugging, I assume I would be in like the developer section. Okay. Samsung USB debugging. Settings, about phone, software information, and tap build number 7 times to unlock developer options. Settings, about phone. You know, 5 years ago, maybe 10 years ago, I would have known that. I used to modify my phones all the time. Jailbreak them, install a new ROM. About phone. I already forgot. Build number. There is no build number. You know what? I'm just gonna tap on my screen somewhere. There is no build number. There's a product name, model number, serial number, phone number, network, IMEI, software information. Let's try that. Build number. Ah! Alright, we're getting somewhere. Allow development settings, yes. Developer mode is turned on, okay. So now what do I do? Then go back to settings, select developer options. Okay, so it was hidden. That's why I couldn't find it. I knew there was developer options. Developer options. There it is. Okay. On bug report, stay awake, enable Bluetooth stack log, running services, auto update, USB debugging. Is intended for development purposes only. Use it to copy data between your computer and your device, install apps on your device without notification, read log data. Oh, something's happening. Allow USB debugging. Always allow from this computer. Okay. Okay. USB debugging's on. You know what? Let's turn this off. I'd rather use my... It's probably not ideal, but I'd rather use my phone. I don't want to confuse anything, so I'm going to make sure I have Android Studio up. Alright. If this works, I will throw the VM back on, just so everyone else can see what's happening. So I don't know if I want to show the phone screen. Okay, so USB debugging's on. Do I have to keep the screen open? ADB devices. Okay. So let's try this real quick. Let's see if it's crazy if it can find it. List of devices attached. Nothing. So I thought. Plug in an Android device with USB. ADB works over USB or Wi-Fi without needing any emulator. Stream logcat. Filter to your app. Option enable KVM in dev container host. This is what I've done before. This is what I just tried to do and it didn't. I didn't do 36.1. Here we go. ADB over Wi-Fi to a physical device or Android Studio on host. If you have Android Studio installed on your host machine with an emulator already running, you can connect to it from inside the container. Okay, so I don't know what the... Okay, this is a pain. This is a pain. We probably have to... in order for me to display everything on the screen, we probably do need to go this KVM route, which I have done before. It is kind of slow, because it is an emulator running in a dev container inside my WSL environment on my Windows machine. But we can do this. It just requires a little bit of finagling. So inside my dev container, I need to run these arguments. After post command. Let's do this. Actually, I want post command. Okay, so that will expose the KVM to my hardware. I need to also make sure I run all of this stuff. Except I just want this in the Docker file and be done with it. And you... Otherwise, I need to create a post-create script, which is what I did before. But I don't remember if there was a reason for that. I think it was because I wasn't building my own Docker file. Can you ensure the emulator and necessary tools exist in the Docker file to support ADB install No. We do not want to stage the out files from Android. I don't know what a flat file is, but it's also general. Okay, so let's take a look at the Docker file now. Emulator runtime dependencies, cool. I was wondering if we needed stuff like that. ADB over USB, USB utils. Okay, so I guess I didn't have that and I needed it. What else? AVD manager, it's going to create an Android virtual device called Awen AVD. System images, Android 3, all that, yeah. Pixel 6, that's perfectly fine. Just don't want it to be running. Create a default AVD to the emulators ready to launch immediately. I think all that's fine. Then we need to remember this. Let's rebuild. I'll be honest, wasn't planning on streaming this long today. I keep looking over. I don't know how true it is, but there is one viewer on Twitch. That is you. And I don't know if you're a bot or what. But you're holding me hostage, man. I don't want to get off the computer if someone's actually watching and wanting to pay attention and learn or figure out. Now, if you actually know the answer to all these problems and you're not helping out, that's also a problem. Is it warm outside? I'm sweating. Turn the AC on. Yeah, see, I'm not convinced anyone's here. Maybe can I refresh this? I don't know how any of this works. I'm talking to myself this whole time. That's okay. I had to figure this stuff out anyway. Am I not live on YouTube anymore? What the heck? What the hey? What's going on there? Suspicious. I'll eventually figure this stuff out. It says I'm live. My phone's not telling me I'm live. Weird. Well, this is saying views, not viewers. Is there a difference? This dev container is going to become so bloated. Which isn't really what you want for like a CI/CD pipeline, but we might need it anyway if we're trying to build an APK. Or if we want to do some pipeline testing, launch an emulator, run some tests. Ooh, I wonder if you can run command line tests inside an Android emulator. Verify your code works. I have no idea what testing looks like on Android. Probably gonna give this one more try once this is built to see if I can at least do an ADB install and maybe figure out what's going on, why it's crashing. If I can't figure anything out, that's okay. I'll end it here, and I might work on it some in the evening or tomorrow. we at least got a single red triangle drawn today. Not everyone can say they did that. I can say I did that. Not every. Actually, wait. I don't think I can say I did that. I think the AI did that. I didn't draw a single red triangle today. Oh, gosh. Oh, no. I couldn't even get a single triangle drawn. Oh, someone text me. What's going on here? My friend beats Solasta 2. I haven't even had a chance to play it. The amount of effort all this is taking, this is why I always just stick to using like something like Qt. It can do all this for you and gives you a CMake script to do it. But I guess there's no fun in that, right? There's no way to learn and improve your skill set, if you will. That's what I thought. There's just nothing here. Oh, hey, I see myself as a viewer. Okay, yeah. Alright, while our waiting for paint dry, I'm gonna cool down the house. See if my cat comes back. It's chilling. Just chilling in the garage. Not a care in the world. And this failed to build. Alright, that's it. I am done with fighting this for now. And I think I'm just gonna have to spend some time either tonight or maybe tomorrow. See if I can figure out what's going on. But I would like to get to a point where I can at least do Hello Triangle on an Android phone and in a web browser. And that gives us a really good baseline for any time I add a code change or a dependency, I can verify things are behaving as expected. Which makes me feel better whenever I commit changes. But yeah, if anyone happened to come by and take a look at my stream, I appreciate it, and I will catch you next time. See ya.